Here's my line tracker robot. As you can see, it is driven by two DC motors. These two DC motors have their own shaft, which goes to a 60-tooth gear, and that 60-tooth gear is enmeshed with a 36-tooth gear, and that gives a higher output speed to each wheel or green wheel on their shafts. I also have a third swivel wheel here that allows for easier movement on the turns, sharper turns. At the front, I have my two VEX line trackers. Those are there to sense when the robot is taking itself off the track and it can readjust itself. Over here we have our motor controllers. Those go down or connect our DC motors and connect it to the Arduino Mega. I made a little shelf here to try and keep the wires nice and neat. Of course, like I mentioned before, here's our Arduino Mega. Over here is our analog ports. Those are going to our VEX line trackers. And then, of course, we have our battery pack here on the side, and that goes and keeps our Arduino Mega powered. So I should explain how the line trackers work. So the line trackers, they produce a beam of infrared light, which then reflects off the surface that it is facing, and depending on the reflectivity of that surface, the line tracker can detect what color it is, or it can provide a value for each color. So in this case, black or black tape would give off a value of around 800 or higher. So a couple problems I have with this robot. First glaring problem was that this swivel wheel was not here before. It was actually a third green wheel, which had its own axle that went straight across and was powered by its own DC motor. But this wouldn't really allow the robot to turn as sharply as it needed to. It also, that third DC motor and wheel didn't have gearing, so I had to account for a separate movement speed for that third axle in comparison to these two DC motors and wheels setups. The other problem was that the robot would often derail itself on turns, overshooting the turns. So to bypass that, I gave it a small delay on each turning movement, or after each turning movement, and then I had it turn in place by making one wheel move forward while the other wheel goes in reverse, while before I only had one wheel moving forward and the other wheel would just sit still. Here's the code for our robot. To clear initialize our motors and our VEX line trackers in our void setup section. Put in our motor inputs, declaring which pins they're attached to and the range of operations. We also print the sensor labels to LCD. Then we have our functions for the robot's movement. Forward, where both motors travel forward. Right, where the first motor goes in reverse, second motor goes forward. And turn left, where the first motor goes forward and second motor goes in reverse. Then in a void loop section, declare and initialize our sensor values, and we print those sensor values on the LCD screen. Then we have our if-else statement, so if the left sensor detects the track, then the robot will turn left. Else if the right sensor detects the track, it'll turn right. And else in all other cases, the robot will just travel forward.